Let's go through LeetCode 1255 maximal score words formed by letters. For this question, it gives us a string words and also string array words and also a character array letters and also a integer score array score. So you see that we can use these kind of letters to form the words. And you say that the word can be duplicated, but since that for every word you can only use once. You see, words cannot be used 2 or more times. And also the letter, you cannot use the multiple times, can only be used once. So, for example, we have letters, right? So there is D, A, G here. So that means dog, right? Sorry, D-O-G, right? Dog. We can at least form a word, dog. If we form this kind of word, then we can check the score of D, right? D is A, B, C, D is score 5. O is some kind of, is 2, right? Somewhere here is 2. And G is somewhere 3, right? So we are get a score, this kind of 5, 3, 2, right? And so if it forms a word, then it will add to our total score. So it asks what's the maximal score we can get use these kind of letters. The things that you don't need to use all of the words, right? But the things that you cannot use one letter multiple times. So how can we do this kind of question? We know this is a score, right? So the word we have options to select or not select, right? So for every word, it has option to select or not select. So for this kind of scenario, what we think about is one is backpack, right? One zero backpack. Another probably is DFS, right? Is select or not select, is combination. So for which directions should we go, right? Let's look at the time range. We'll see the word length is 14, right? So 14, okay. So we know if it is 14, if we do the backpack, right? So it is n multiplied by weight. That is the time complexity, but this kind of weight is very hard to simulate, right? So letters, the length is 100, and for every letter, it may have different combinations. So how can we simulate the weight is a problem. But the thing is, if we do DFS, right, backtrack, DFS, every word has the option to select to or not the to the power n, right? So to power 14. This should be still good enough to do the DFS. So let's look at the DFS word, right? So what we're thinking about is that it give us these kind of letters at the beginning. So we do a frequency summary, right? Get the counts at the beginning to be 26, get all of the character we can use. And then we need to, for every word, right, we need to have the options to select or not. So every word, if we select, we should have something to record how many characters we used, right? So we should have another interarray called current, which means how many A's we have used. We can have 26, size 26, right? This is count is the total we can use. So when come to this kind of, for example, word index, right, or word I, we try to see whether this kind of word can is able to add to our data structure, right? So that is that we just compare from A to Z. If the counts is any of A to Z is greater than our initial counts given, right? Then that means this kind of word is not able to add to our data structure. Then if it is able to add to our data structure, then we do the backtrack, right? We add it, update the total score, and then DFS to the next layer, and then update our current counts back, and also the total score retrieve back, right? So doing DFS, and then I think it will be 2 to the power length, right? So that is 14, and possibly they may have some kind of n operations inside. That's a radical phase. And we can analyze that time complexity, space complexity later, right? So we know we need to have the initial counts, of course, new int 26. And what we do is that for character string letters, we have counts string minus a. Get this one, right? Let's have a reference result type. In the DFS something, right? Return result there. So for DFS, what we should have, right? We should have the word array, right? Words array. We should have a score array to consult, right? Also our index, current index, and this one is from A to Z. Currently how many we already used, right? And this is the total we can use, and this is the current sum, okay, and the result. Okay. So let's say if sum is current sum is greater than result 0, right? Then we just update result 0 equals current sum. And let's iterate the words array, right? For int I equals index I smaller than words dot length, okay? I plus plus. And let's get this word count out equals words. So we also should count word count. Should be new int 26. In word I, which array, right? So we should have word count C minus A plus plus, right? We're going to use a Boolean variable to called can add equals true, right? And what do we do is that for j int j equals to 0 is smaller than 26, j plus plus, and let's say if current j plus word count j is total than the total the counts given, right? For any of the A to Z, then we'll say can add equals false, and then we need to break. Break this for loop means we are not able to add this kind of word, right? So this one will be trimmed. And we'll say if we can add then we are able to do the backtracking, right? So for the backtracking is also for int k equals to 0, k smaller than 26, k plus plus. So what we do is that we should have a current j should plus equal to word count j, right? And also what about the score? Current sum, right? Current sum should plus equal to score k multiplied by this word count, okay, right? And we should backtrack, right? And also we should DFS. So this should be minus equal to, and this should be minus equal to, right? Then DFS words score in I plus 1 and current count, current sum, right? Result. So this will be the code. DFS we haven't implemented yet. Words score 0, right? At the beginning, it should be 0. This current should be new into 26. And this will be the counts total we can use. And the current sign is 0 and the result. Should be K, right? This should be K. K. Well, say this time complexity is the latest length, right? And for this kind of DFS, for example, the word length, if there are n words, right? So that is 2 power n. And 2 power n for every word, right? We should have the word length. For example, the word length is W, right? So that were 2 power n multiplied by average of the word length. Of course, we also need to multiply by 26, right? That is because there is a 26 checking. So will be all this, right? And also there is initial count. So it's all score length, a letter length plus all 26 multiplied by 2 power n and the average of word length, right? Let's convert this to Python code. We know we should have result count equals, let's have result at this, right? Count equals this one multiplied by 26. And for C in letters, we have count ORD C minus ORD A plus equal to 1, right? And then we should have DFS something, and the return result 0. So for DFS, right? So DFS is DFS. DFS we should have words. This is a list of string, and we should have a scope. This is a list of int, and we should have index. This should be an int current, right? This will also be a list int, and we should have count. This also be a list of int, and we should have current sum, right? This should be an int. We should have a result. Which should be at least int. So let's say if current sum is greater than result 0, we're going to update result 0 to be current sum, right? So what we do is that for I in range from index to length words, we are going to have we should count this kind of words, right? Should also be this one multiplied by 26. So for C in words, we shall have word counts ORD C minus ORD A should plus equal to 1, right? Let's set can add equals true at the beginning. And what we do is that for J in range 26, if current J plus word count J greater than the one given, right? Then can add equals to false, and we should break, right? And then what we do is that if can add, then we for k in range 26, we're going to update the current accounts, right? Should plus equal to w count k, and also we should have current sum should plus equal to w count k multiplied by score k, right? And after this, we should backtrack. This should be minus equal to. This should be minus equal to, right? And then we should do DFS here, right? DFS words score I plus 1 current count C sum result. We haven't implemented yet. So the DFS should be words and score. This is given to us, right? So at the beginning index is this index is 0, and we should have this one multiplied by 26 to put our current counts and the counts initial sum and the result. Okay.